And welcome. Thank you for spending this hour with us. My name is Brad Brown. I'm an instructor with WebAge Solutions, and I am an independent consultant. Many of the people that WebAge uses for course delivery are we're practitioners. This is what we do kind of all the time. By way of introduction, I spent most of my career at Loblaws. Loblaws is the largest grocery retailer in Canada and the largest private sector employer. And I spent almost 20 years there doing absolutely everything there is to do in IT. And at various times have been responsible for applications development across the country and operations across the country. And I've been independent for about 10 years. My practice largely revolves around a number of subjects, but the one that's nearest and dearest to my heart is architecture, particularly solution architecture. And that's what we're going to talk about today. Architecture, when I say architecture, when I find my cursor there, hello. We're going to spend a little bit of time today talking about architecture. And when I say architecture, I think most people will think of the architecture of a building. And sometimes this architecture is enduring. Buildings can last longer than the civilizations that created them. Sometimes the architecture of a building is a testament to our ability to create things that are grander than the simple purpose of its creation. And architecture can lead to buildings that are both fit for purpose. They meet a set of objectives, and they're very pleasing. It's a real pleasure to work in them and be around them. You know, it's not easy for me to find graphics that illustrate this point, but computer systems have architecture too. And the architecture of the software that you use, the software that you write, it matters just as much as the architecture of a building. What we're going to cover in the next little while is what is architecture? What are enterprise and solution architecture, and how do they work together? We'll talk about what's the difference between architecture and design. And we'll close with what does it mean to solution something well. Now, before I go on, because this is a fairly large session, all the participants are muted. But I would like to invite anybody who has a question or something they want to raise, even right in the middle, please use chat. We'll have a little bit of time for Q&A at the end, but I invite you to participate, ask questions, point things out. That's perfectly cool. And I do want to let you know a couple things. This session is being recorded, so it can be made available to people who can't make it today. And we are going to take a few minutes at the end during Q&A to ask I'm going to ask you to complete a short survey to get some feedback on the session today and your interests. So please do stick around for that. Let's start by talking about what is architecture. Well, when we talk about the building architecture, you kind of have an intuitive sense of what that is. You could think it's the shape, the style, maybe the way the components fit together, the way the building flows, how it fits in its environment. Well, in software, it's actually kind of the same thing. When we speak of architecture, we mean the fundamental organization of something. And that organization is embodied in its components, the parts that make up the something, the relationships of those components to each other, and the relationships of those components to the environment. And it is about the principles that govern the design of the thing and the evolution of the thing. Now, I use the word something very deliberately, that very vague word, because something could be a building, but it could also be a business. It could be a collection of several business partners who work together. It could be something inside a business, claims processing capability. It could be a system, an application. It could be the way that you do a number of things inside a business. All of those things fit into this category of, well, things that can be architected or things that have architecture. And one of the things that is characteristic of things that have architecture, at least architecture that we've thought about, is that something that's been architected has recognizable patterns of organization. In other words, it's not just a heap of things that's been assembled together. It's not a pile of bricks. It's something that has structure and form and organization and order to it. That architecture, it reflects what's important to the organization. It reflects what's important to the stakeholders in the organization. And in the context of things that are relevant to business, it reflects those things that are important to the business problem at hand. Now that architecture it's kind of a broad idea. It could be a lot of different things. And traditionally in architecture, at least computer architecture, we think about dividing the space of things that we think about into domains. And the reason for this is to be able to think about things without getting totally overwhelmed. It also lets us think about something without getting kind of caught up in the details of something else. Traditionally, the 4 domains or kind of divisions of architecture that we look at in business systems and in computing for business are business. The business domain or business architecture consists of those things that are about the business organization, its processes, how it works, what it does, what capabilities it fulfills. It's the things about the business that really make up the business, but it doesn't have anything to do with the technology. It's divorced from the technology. The application architecture or application domain is about the software that actually implements those business capabilities. It underlies them. It kind of supports those business abilities and business processes. And that set of the application domain is all those things that you use on a day-to-day basis. Your ERP system, your email system. Those applications manipulate data, information. The information architecture or information domain consists of the data or information about your business, about the processes, about the things that you're doing, the transactions that you're performing. And lastly, the last domain is technology domain. It consists of all the things that kind of support those. It's the servers and infrastructure and network or cloud, all the things that allow this to happen. Now, then why do we bother to divide this up into 4 different domains? Well, it's because we want to be able to think about them independently. I want to be able to think about a business process independently of the applications that are used to support that business process. And I want to do that because I want to be able to think about things that are happening in business without getting all caught up in the technology. I don't want to think about business as the way the application works. I want to be able to think about business as purely what the business should do, what people want from it, what it does now, what it should do in the future. That helps me think about applications as a separate thing. It lets me think about application. Okay, go away, please. Not now. I know. This is what happens when we have webinars at the end of eSchool. Okay, off you go. So the application then, it's got all these capabilities. It does stuff, some of which we're going to use in business processes. Some of which might be other things. They're kind of unrelated. They're capabilities we don't actually use. Data is an interesting one. Why would I keep data separate from applications? Well, data is actually more important than applications. Data is kind of more central than applications. It certainly lasts longer than applications. Think about the information that you have about customers. Well, you may have one CRM system and you move to another CRM system and you have some data that's stored in your ERP system or your purchasing or whatever. All that data that may be touched by several different systems that change over time and may come and go, the data lives on. The data is kind of central to this whole ability to run a modern business. And lastly, I want to be able to think about technology as a separate thing, not kind of get caught up with the particular type of server that's used for this particular type of application. By dividing our thinking about what architecture is into these separate domains, it allows us to focus on relevant problems, relevant concerns of each of those domains without getting all kind of caught up in others. Okay, so there's a little bit, just a tiny taste, because we only have an hour, a tiny taste of what architecture is and how we think about it a little bit in how we divide it up into things. Some of the tools, practices that we have for using architecture, developing and using architecture include enterprise and solution architecture. Now, enterprise, okay, it's actually not like about the Starship Enterprise. It's actually about kind of the bigger picture. Enterprise architecture is a practice, a set of practices in architecture that's concerned with the entire enterprise. Kind of loosely speaking, In enterprise architecture, what we think about is, what's the future vision of the organization, maybe 5 years away? What's things like today? How does it work today? What are the things that we need to do over the next 5 years to get us from where we are now to where we want to be? What's that kind of set of steps that would transform where we are now into our future state? And this roadmap, this visioning and roadmap, helps guide the organization to realize that vision. It helps set a target. It helps guide decisions. Now, that target may change. 5 years from now, we may not actually be doing what we thought we were going to do at this point. The roadmap may move from time to time, but it's always this beacon off kind of on the horizon that we can move towards. And it gives us a way of thinking about what are the right ways to be able to realize the vision in a relatively efficient and effective way. So enterprise architecture also is concerned with all 4 of those domains. Remember, business, information, applications, and technology. Enterprise architecture helps form that roadmap for each of those things, which I think helps illustrate why these 4 concerns in architecture should be kept separate. Part of enterprise architecture should be thinking about where the business is going on this kind of longer term timeline, and then fit applications into that, supporting the data that's necessary to run the business. And the kind of things that you may realize, for example, is your future vision. Maybe your future vision is to be able to sell services directly to consumers and augment their retail network. What would you need to do to be able to do that? Well, you probably need to know a lot more about your customers. So what data would you need to know about those customers? Well, you could figure some of that out. How would you start to get some of that data? How would you share it with people? What are some of the relationships between retail and kind of this kind of center that needs the data? What applications would you need to be able to support that? Okay, so you see this train of thought leads us to a thoughtful and well-intended roadmap that we can use over time. And at a high level, that's kind of a lot of what our enterprise architecture is all about. But enterprise architecture is typically about future vision and planning, if you will. Whereas this other form of architecture, solution architecture, is concerned with the specific solutions, the structure and organization of particular solutions. Now, what is that particular solution? Well, it might actually be one of those things that come from the enterprise architecture roadmap. Could be, one of those things that's on that path that we're following. It could be a tactical project, something we have to do right now. Could be, some initiative that we have to perform because of, regulatory reasons. Maybe we have to kind of come up with, I'm actually working with a client where part of what we're doing is we're re-architecting how the organization manages the data that knowledge workers produce to better support an ability to be remote and work from home. Well, it's kind of obvious what the impetus for that was. Usually, but not always, solution architecture involves some form of software. It could be an implementation of software package. It could be a modification of something that already exists. It could be a development of something completely new. I say usually, but not always, because solution architecture isn't necessarily just about software. It can be also about business processes. It could be about how we work. It could be about how an organization is divided up, governance to meet particular objectives, are all subject to this set of practices around what solution architecture is. Now, I'll go into a little bit more detail about what it is in a moment, but why is it actually important to think about solution architecture? Well, there are actually a lot of reasons, but a few of them that make this such a critical thing to think about is well, I'll do it in the order that's here. The architecture of a solution, remember that's its structure and organization, kind of that high level blueprint of a solution. That architecture carries some very fundamental design decisions. It's those things that we thought of kind of first, the big decisions that we made about how a solution is going to be organized, what it is and how those things relate to each other. So we make some very, very early design decisions, and it turns out that a lot of those design decisions become things that are very, very difficult to change later. Not because there's anything special about them or they're more important or because solution architects are deeper thinkers than anybody else. No, it's because when you make a decision up front and then you kind of run with it for a while, you may realize down the road that wasn't really the right decision. And it's a lot of effort to back up and redo it. Often you throw a lot of things away. So the decisions that we make early tend to live with us for a long time. So it kind of makes sense that we do that in a very deliberate, thoughtful way. Now, another thing that happens when we have a solution architecture is, well, we kind of have to write this stuff down. And having a documented architecture helps us work with stakeholders and communicate between stakeholders. Stakeholders, just anybody who has a concern, an interest in the solution. And part of what happens in development and solution architecture and kind of any particularly major initiatives is we have a number of different stakeholders and they have different concerns, often conflicting concerns. So one group of people might think it's really, really important that our solution be something that can meet the needs of hundreds of thousands of our users. Whereas somebody else is really concerned about cost. And somebody else might be really concerned that it gets done tomorrow. Well, usually you can't have everything you want. So we have to communicate. We have to come to agreement. We have to get people to see trade-offs. We have to get people to understand what the solution is and what it isn't. All of that requires communication. And having a documented architecture fundamentally enhances that ability to communicate amongst all these different stakeholders who are important to us. Having that documented architecture and having made some decisions allow us to reason about what will happen as this system evolves, how it changes. We can reason about things like, here's a solution for this customer-facing application that engages directly with people for whatever it is. And because I understand what the architecture is like, I can predict what will happen if we need to, say, vastly increase the number of users it handles, or change its capabilities, or add some new functionality to it. And as the system evolves, I can manage that because I have an architecture. And the last thing that's on this slide, though there are lots of other reasons why solution architecture is important, is it helps guide alternatives and it channels creativity. So rather than a solution architecture being something that kind of binds the hands of development, it doesn't restrict people. It actually gives us freedom. It gives development, design and development, freedom to understand where's this going? What are the kind of major things they need to do? And then in that context, to build the best solution they possibly can. It seems a little counterintuitive, but it turns out that if you just kind of dump a heap of requirements on somebody and say, build something, and they don't have kind of design around it, an architecture around it, typically what happens is they're very creative in kind of scattered ways. And you end up with something that requires a lot of effort to pull it together and make it actually work. Here we're hoping that people will avoid some of those pitfalls so they can channel their creativity into actual kind of business value adding activities and therefore satisfaction. Now I'm just going to skip a slide here because I talked about stakeholders already and we're watching time. Now, I've been talking about architecture as being about the structure and organization of a solution. And why is this constant focus on structure? Well, first of all, what do I mean by structure? I mean what it is that the solution consists of, what its parts are, how they work together, how they're related to each other. In software, this might be major components. In a business process, it might be a connection between a number of different people and how they work and some business systems, and the way that they relate to each other. We focus on structure because we want to be able to treat those pieces of a solution, those components, effectively as black boxes. If I can treat a component as a black box, I don't have to understand what's going on inside it. That reduces the amount of detail that I have to think about. Now, it doesn't mean that detail goes away. It means I can kind of put it off for now. And at some later date, I'll open up the box and I'll see what's inside and I'll think about it and kind of reason about it. But until then, I can put it off and think about the bigger picture. Focusing on structure lets me think about what's the big picture. It lets me separate concerns between what the big picture is and the details of how you implement those pieces. It lets me treat the architecture of a solution as an abstraction, a simplification of the overall system. And that's an important idea because it lets me effectively manage complexity. I don't have to try and understand everything all at once. I can understand the bigger picture, and then I can open up the box and look inside and drill down a little bit and figure out the structure inside that box and kind of over and over again. Now, of course, there's more to it than this, and in the longer course, we'll talk about this in more detail. But the idea that focusing on structure lets us control the level of detail, lets us think at an appropriate level of abstraction, is an important concept in architecture. Now, I did see a question here. This is a great question, by the way. I'm going to kind of talk to that in the end because this is a good wrap-up question. Now, if I'm focusing on structure, I'm focusing on the big picture, well, how do I actually know what to think about and what not to think about? Well, there's no magic answer for that, but one thing that we use as a tool is this idea of architectural significance. The idea that not everything that's important is actually important to the architecture. There are lots of things that are important, particularly about software, that don't really affect the structure and organization of an overall solution. And therefore, they're not really important from the point of view of architecture. Now, let me be really clear. I'm not dismissing these things as unimportant. They're just not architecturally significant. What are examples of things that are architecturally significant? Well, there's all kinds of stuff. For example, an auditing requirement. If somebody came and said, you have this system that sells things to people, and now we need this mechanism for being able to audit which sales went to, I don't know, which countries, say, just arbitrarily. Well, that could be an architecturally significant change in the sense that it might require you to build a new component, a new part to the application, to produce a new report, a new output, a new interface, whatever it happens to be. If it affects the structure and organization of the solution, it's usually architecturally significant. But there are lots of things that really aren't architecturally significant. Think of something like an application that's your users, that communicates with users. And maybe you make a design decision that numbers which are negative should be red. Okay, maybe it's reporting financial information. Well, that's great. That's probably a very important requirement. It doesn't change the structure and organization of the solution. It's just not architecturally significant. We architects use this notion of architecturally significant to help filter out what it is that we have to kind of consider and deal with. And there's no kind of magic tool for knowing what's architecturally significant. But this tool, this mechanism for allowing us to think about what's relevant and what's not for the architecture is just another thing that's about managing complexity. Now, I'd have a lot more to say about that if we had more time, because I find this a very interesting area, and that the whole notion of architecture as a tool for managing complexity, I think, is a very interesting one. But in the interest of time, we're going to move on to another somewhat related topic. That's about architecture and design. So a lot of the things that I've been talking about in architecture, you might be kind of thinking, particularly if you've done software development or software design, you might be kind of thinking, gee, what he's saying, sure, but isn't that kind of design? Well, architecture and design are closely related. And in fact, they can be hard to distinguish. And in reality, there's no perfect divider between architecture and design. I find the distinction between them fuzzy and a matter of perspective. And honestly, it depends on what you're doing and with whom you're doing it. I've been in situations where I can deliver something that's very high level to a team who's going to take it and run with it. That's clearly architecture. I've been in situations where I've done kind of an equivalent project, but I have to deliver something that has a tremendous more detail. because the people I'm delivering it to, they just, they don't have the design expertise, software engineering expertise. So the architecture that I deliver has a lot more to it than that. But in general, architecture is supposed to be about the big picture, the context, the strategies that should be used in a solution. Architecture is relatively abstract, and the word relatively is important. It's not got an absolute distinction. It's relatively abstract. Maybe the best way of saying this is architecture is about what to build. There we go. Design is more about the details. It's more about the implementation, the construction. Design is relatively concrete. Design is more about how to build. So one way that this comes up often is an architecture. You could often do an architecture for a solution without really worrying too much about what the implementation technology is. I can design something and it's not really that important whether this web server, this web service, is it implemented in Java with struts, or is it a Node.js, or what is it? From my point of view as an architect, a lot of the time, don't really care that much about that. It's not that important. Now, if you're going to design, it's obviously super important. And that's an example of the difference between architecture being relatively abstract. I talk about what it is, how it works. It's behavior, observed behavior, not how to actually build it. And I just noticed a question. Yes, slides will be available. They're going to be distributed later, and I think probably recording as well. To put it another way, architecture focuses on the structure and organization of the solution, somewhat abstractly, and it does not focus on how to do things in some particular platform. Generally doesn't focus on things like look and feel and a whole bunch of other things about how to actually do something. Whereas design focuses on how to create what it is that the architecture described. And design focuses on creating this software using specific tool sets, specific methods, by having a detailed plan, a design for what it is that we're going to build. And this design, here's a critical link between them, is guided by the description of the architecture, by the structure and organization that's laid out by the architecture. Architecture guides and leads design. So then what is it that makes, what is it that we are trying to achieve as architects? Well, and frankly, as guiders of good design, well, we're trying to lead us towards a good solution. And what makes a good solution is very subjective. As an architect, we can usually look at something and say, this feels good, or this doesn't feel good, or this part of it is kind of awkward, or we don't like this. And in very specific cases, we can tell you why. It's hard to do that without a concrete example, but there are some characteristics of a good solution that we'll see commonly. And one is that the solution can meet the functional requirements. It does what it's supposed to do, as long as it's going to be designed and built according to the architecture. Now, this sounds kind of obvious. Why would a solution ever not meet functional requirements? Well, in fact, there have been a lot of times when people have built a solution and it actually doesn't meet the requirements. And part of the reason that happens sometimes is people, sometimes teams, charge ahead. They underestimate the complexity of something. They don't think ahead about the structure and organization. They just do some stuff. They run out of time. And what you end up with is a piece of software that maybe doesn't actually do all the things it's supposed to. It's a problem. A good solution is one that, well, it actually does meet those functional requirements. But it's not the only thing that makes a solution good. A good solution also meets non-functional requirements. Now, non-functional requirements. This is a really interesting area for architects. We love this sort of stuff because non-functional requirements are those they're characteristics of what's going to be built. It's performance, it's availability, it's extensibility. These non-functional, or sometimes called quality of service requirements are really about kind of how a solution will be able to behave and change in the long run. Now, a good solution has desirable non-functional requirements. If I have a particular availability requirement, it has to be up, 99.99% of the planned uptime. Then a good solution is one that will actually meet that requirement. And architecture helps us do that. It turns out that a lot of these non-functional requirements, it's very, very difficult to be able to say whether you're going to be able to meet them or not without having an architecture. But having an architecture, having a structure and organization of a solution gives us something to reason about. It gives us something where we can think about what's the performance likely to be. Take something like scalability. I have an application. It's our customer-facing application again. And one of the requirements I might have, the non-functional requirements, might be to be able to scale up to support a very large number of users. Well, it requires forethought to do that. It requires planning to do that. It requires the application to be designed using certain patterns, certain ways of doing things, so that we're able to do stuff like, for example, have a solution that can run on multiple machines. And I can add some machines to this pool of machines that are being used on demand. Now, that doesn't just happen. That requires considerable forethought and planning to enable that. So a good solution is one that's been architected to meet those non-functional requirements. There's another one that I want to touch on here because it's kind of another important one. Because it's not just about the requirements. It's also about other characteristics, like our ability to maintain or change an application over time without too much rework. The ability to be able to adapt a solution to a new set of requirements. Business needs change all the time. Marketplace changes, we discover new things. Somebody reads an airline magazine, wants a new solution. There's all this stuff that we need to be able to evolve into our products over time. And it turns out that a good solution, well-architected solution, a well-designed solution, is one that, because of various characteristics of how it's been designed, it's relatively easy to change without messing it all up. That I can extend it to new pieces of functionality. Maybe when we were architecting the solution, we anticipated some of the needs that we'd have in the future. So kind of simple example is, this is a real one from my work. We're building a solution and it interfaces with a third-party service provider. But we kind of think, no, wait a minute, we're dealing with AcmeCo as our third-party service provider now. But a few years from now, what if somebody comes along and we want to deal with another one? Maybe somebody's a better partner. Maybe AcmeCo goes out of business. This particular solution, this is a real solution. This particular solution, we had a couple choices for how we could do something. We could wire it directly into AcmeCo's API. But we decided not to. What we decided to do was implement a little layer inside that was an abstraction of AcmeCo's API. We could talk to it. And the reason was we had all these different parts of the application talking to this. We centralized it all in one place. So everybody inside the application talked to this one place. One place talked to AcmeCo. Why'd we go to all that trouble? Because if something changed in AcmeCo, or we wanted to go to, BCO or something like that, we could do it by changing things in one place. That's an architectural solution. And the reason for that was to be able to make the application easier to maintain and easier to adapt to potential changing business requirements like a new partner. That sort of stuff doesn't just happen. Now, another thing about a good solution is a good solution should be something that's easy to understand. And what I mean by that is, I don't mean from a user point of view. I don't mean from a usability point of view. Good solutions are usable, but that's not where I'm going with this. A good solution is one that you onboard a new person to the team. Alice joins the team. Alice should be able to look at a solution, kind of read some of it, read some documentation on it, read some source code, and kind of go, I get how that works. I understand that. Now, it's kind of a hard thing to measure, but it turns out well-architected and well-designed solutions, they're a lot easier to understand That's important, not just for Alice, who's just joining the team, but to help us be able to maintain and evolve the application over time. When we don't have these things, we don't have this good solution, a well-architected, well-designed solution, what tends to happen is we get this thing that we architects have a term for. It's called a ball of mud. Ball of mud is an application that started out, maybe it started out well, but over time, people have just patched it and they've added stuff to it. It's like kind of just adding little bits of mud to make it do something. And over time, all there is this big ball of mud. And it's a very pejorative term, but it's meant to indicate those applications that they didn't really have, or nobody stuck to, a design. So people just bolted on stuff and stuff and stuff. And eventually you get to the point where you just don't know what to do with it. Now, some of the things that you'll see if you avoid this is good solutions have some characteristics. We can feel kind of what they're like and what works in them. Some of the characteristics of a good solution are that the different parts, the components, they have a very well-defined purpose. I can look at this thing. Maybe it's a class. Maybe it's a subsystem. Maybe it's an entire application that's part of a larger whole. And I can say, I know what that is. It has a very clear, well-defined purpose. It doesn't do 67 different random things. It has a role in its life. Not only that, but the parts, those different components of the solution, they're related to each other following simple patterns. The slide says connected, same idea. A solution consists of a bunch of parts, different components, and their relationship to each other, their connections to each other. And a connection can be something as kind of concrete as this component and this component are compiled together and they're bound together and they're deployed in a single WAR file. If it's a Java app. Or it could be that this thing, this component here, this is a customer lookup service and it presents an API and other parts of the application are calling that API. That's a connection as well. Good solutions tend to have parts that are connected following simple patterns and well understood patterns and in a regular way. They're not just willy-nilly all over the place. Then I could look at a diagram of a well-architected solution and I'd see how it hangs together and I'd see kind of patterns of interaction that they just kind of make sense. A well-architected solution, good solution, tends to focus on interfaces instead of what's inside the interfaces, what's behind the interfaces. In other words, when I look at a well-designed solution, the place my metaphorically eye is drawn is toward those interfaces, toward the connections. And I don't have to spend a lot of time thinking about what's inside the components. That's an indication, and I know this is a very hand-wavy description, but that's an indication of something that's been put together well with some good thought into what are the parts that interact and what are the kind of pieces that connect together. And almost lastly, it's not just the connections between the parts, but the organization of the parts, the kind of way that they're put together, that follows known patterns. There's established kind of ways of doing things. And the application takes advantage of that. Now, it's kind of hard to do without some examples, but there are common ways of putting together applications. It's a kind of an oldie but a goodie. Your three-tiered application. So this is kind of, we've been doing this for a really long time now as an industry. But the idea that we'd have a user interface, usually a web server, that talks to a bunch of business logic, application server, that stores a bunch of data inside a database, well, database server. That's a known pattern. That's a way of doing things. And that particular kind of application, it has certain characteristics. It does certain things well. Some things, not so much. But I can look at that way of doing things and I can say, I recognize that. I know that pattern. I know what its advantages and disadvantages are. And maybe I could look at that pattern and say, no, that's not appropriate for this particular use. I should really be doing something else. because that pattern doesn't really work. It doesn't scale to the extent we need to, for example. And that is an example of those early design decisions that carry great consequence later. The nut of this, the kind of summary of this, is that a good solution, it should feel almost like it's obvious. An architect has really done their job well, and frankly, a designer has done their job well. When somebody looks at the design and it's so obvious, they kind of go, yeah, why just spend all that time on that? Well, in fact, it takes a lot of time. It's much more difficult to do something well than it is to do it kind of less well. It just doesn't feel like it because the solution is just so clear. In fact, a good solution is beautiful. Now, you may have to have a certain amount of nerdiness to appreciate the beauty in software. But, you know, beauty is, it's something you can't describe, but as architects, we know it when we see it. Designers do too. Developers do too. You know when something's a beautiful solution. So a well-architected solution is kind of like a well-architected building. It doesn't just do what it's required. It's not just kind of there doing the basics. It's not the concrete block. It does what it does. It does what's required in a way that will be able to grow and adapt. Most importantly, endure as the business environment changes, as our needs change. Which brings me to the end of the kind of prepared comments. Now, I just want to check for a second here. Do we have, sorry, I'm just looking to see whether I have Tim or Prem, because I changed up the order here a little bit. I was going to do a quick intro. Yes. Okay. I'm finding them so that I can unmute. So Tim, Prem, I was going to throw it to you in the beginning to do a little bit of an overview, and in the interest of time, I just got started. Now I'm looking for you in the attendee list to be able to unmute you. Oh, they think, okay, I think they're the phone numbers. Okay, there we go. I got two people who've dialed in. So I've just unmuted them because I think you are Tim and Prem. So the dial-in uses you're unmuted. Have I got it right? Well, okay. Tim, Prem, if you're there, if you raise your hand, I'll be able to find you and unmute you. In the meantime, I do have a one question on content. Any other questions, please enter through chat. And if you wouldn't mind taking a few minutes and complete the Survey Monkey. And Tim is here. Yeah, Tim, I know you're saying you're raising your hand. I don't see you on the participant list. That may be a Zoom bug. Yes, I will post the link. Yeah, I don't know if I can unmute everybody. See, I can unmute people individually. Yeah, TSK02C doesn't show up. That's the problem. The list is not complete. And I'm refreshing it, but it's not giving me. Yeah, please relay questions. Absolutely. Okay. Sorry. In the meantime, I'm just going to send out a link here. Okay, now, in the meantime, so I do have a question from Eric. Thank you. What are the best tools, documentation methodologies to design solution architecture with, since documentation of the solution architecture is important? That's a super loaded question. Let me address it in two ways. First of all, tools. There are kind of two ways of looking at this. You can look at architecture-specific tools, and you can look at kind of more general things. Architecture-specific tools would be things like, there's things like Sparks. Sparks EA is a tool, Windows-based tool, very, very popular in the industry because it's quite reasonably priced, extremely powerful, lots and lots of capabilities. Okay, yay, sounds great. Often what we see, and my personal preference, is not to use specific tools like that, but the things that everybody uses, Visio, Word, Excel, things like that. And the reason is communication, the ability to work with other people. As soon as you have specific tools like Sparks, you get this high priesthood of people who know how to use the tool and frankly have licenses for the tool. And then all the people who don't. Everybody's got Word. Yeah, maybe not everybody has Visio, but that's okay. And here's the bigger message. The tools are whatever works. It's whatever works for you. I like the Microsoft Office suite. I'm on a Mac. I use a different drawing program rather than Visio, but it's okay. And then other things like, frankly, a whiteboard. Just being able to get in front of people and talk. That's important. Yeah. Another way of looking at this same problem is, how do you produce things in a particular way? So we have some relatively standardized ways of doing things. In architecture, we have a well-accepted set of artifacts, particularly diagrams, that have specific meanings. A lot of those are based off UML, plus some other things. There's a diagramming technique called Archimate that's very, very expressive. And again, it's what works. These diagramming techniques, they have the advantage of being things that are widely supported by pretty much any professional drawing application. And for the most part, a lot of them are things that are well understood by people. So it's a reasonable thing to do, to just draw diagrams that kind of make sense to people. Diagrams aren't enough. You got to have text as well. And we want to capture our diagrams and text in kind of documents. And we want to be able to collect these together and have them in some standardized forms. So a lot of organizations will standardize things like a solution document, a solution design document, or a solution architecture document. There's a kind of commonly used format organization called the 4+1 views that a lot of architects will use if they're not kind of guided by something else. And it's a nice way of kind of gathering together all the different aspects, the different ways of looking at an architecture of a solution in a kind of reasonable way. And I'm getting a few notes here. Sure, when you're using Evolution, I have to admit, I don't know that one. And you're also using Abacus, I think that's a product, and Archimate as a standard, drawing standard. And that's something you can do with kind of any tool. So any other questions, comments? And why is it? So Tim Prem, I see you in the comments list, but you don't show up in the participants list. This is a Zoom problem. You don't show up in the participants list so that I can manage your muting, and I don't have a way of unmuting everybody. Okay. Well, then if there aren't any other questions, I want to thank all of you for your time and participation. I hope this was useful. Slides and a recording will be distributed, I think a recording, will be distributed later. And this is all material that's been drawn from, frankly, a 4-day class. So you can imagine how much we're just touching the surface here. I do hope that I'll have the opportunity to see some of you in one of our classes at some point in the future. Again, thank you very much for your time, attention, and enjoy the rest of your day.